Hello and welcome to my YouTube channel. This is Ramani Online Mathematics. Today I'm with my cup. We are going to look at this question. In fact, this question was given to me by one of my students, and the question goes this way: solve this: x minus y ux plus x plus y uy equals x squared plus y squared. And there was initial condition given as u of x comma 0 equals x squared. So that was the question. Okay, so this is how the question was like. Good. So now if you want to solve this, I will prefer to use them. You see, this is pDE. So I will prefer to use method of characteristics. We have a lot of method which I have it on my page. You can check from Ramani Online Mathematics. You move to playlist, then you check for the other one, change your variable, the method of characteristics, and the rest. So here, if I want to do this, the method of characteristics is given as the x over a equals dy over b equals du over f. The a is the coefficient of the ux, so x minus y is a. So here we have the x over x minus y should give us dy over x plus y, and this should give us the u over x squared plus y squared. Is that okay? So this is what we have. Now you know how to use the method of characteristics. If you don't know, you can go and watch the video, as I said. Okay. Now looking at this one, if you want to use the method of characteristics here, now you can pair two. Okay, but here in such a way that the pairing of that two will be easy for you to integrate. But if you look at this, if I pair this one and this one, it will be very difficult. So what you do here is that here if I multiply here by x over x and I multiply here by y over y, let's see what you will get. Here by x over x, y over y, let's see. It's going to give us x dx over x squared minus xy, right? And this will give us y dy. Y times this will be, you see this one is multiplying everything here, okay? Don't forget. Xy plus y squared. And this is equals to du x squared plus y squared. Now after doing this, let's add them. So for you to add them, we have our x, the x plus y dy all divided by, you see when you are adding this and this will go to 0, leaving x squared plus y squared is equals to du over x squared plus y squared. Is that okay? You could see that this and this are the same. So if I find LCM and multiply by both sides, you see that this and that will go, leaving x dx plus y dy equals du. It's easy to integrate this. How do you integrate this one? This is going to give you something like this. If I integrate x, that gives me x squared. If I integrate y, that gives me y squared. Everything will be over 2, okay? Over 2 equals u plus, let's say, the constant c. If I multiply through by the 2, I'm going to have something like x squared plus y squared equals 2u plus c. If I multiply c by 2, I still get c, because constant is a constant. So here I'm going to have my c to be equals to x squared plus y squared minus 2u. So let me name here c1. Okay, so we have c1. We have to get another constant, okay, so that we can equate them. Now for you to get the other one, here I have my dx, it was over x minus y, and dy was over x plus y, and this one was equals to du, which was over x squared plus y squared. Now here too, um, hmm, it's difficult if you choose this one and that. It will be difficult to solve. This one and that, it will be difficult to solve. If you choose this one and this, let's see what you are going to get. If I take these two, taking this one off, then what I'm going to do here is that if I pick these two, I'm going to have um, the x over x minus y equals the y over x plus y. I want to make the y, the x the subject. Means that I have, let me do it here. I'm going to have the y, the x to be equals to the y, the x. So it means that um, this one is coming and this one will be here. So it's going to be x plus y, x minus y. In fact, when you get something like this, sometimes the getting the answer becomes difficult. But this one is typically ODE. And we have something like this in ODE. The only way to solve is to check whether it's homogeneous or non-homogeneous. When it is non-homogeneous, you reduce it towards homogeneous. So this is typically ODE. If you don't know how to go about this one, you can check from my playlist, Grammar Online Mathematics, my playlist. You see ordinary differential equations. Search, you see how to solve homogeneous equation, non-homogeneous equation and stuff. So take care of that. Now dy dx equals x plus y over x minus y, right? So the homogeneous equation, the theorem says that, let's say if I have f at lambda x lambda y, then after I'm done solving it, I should get this x y. That lambda should be out and it should be power 0 multiplied by the function itself. Okay, so that's what you should get. So let's do that and see. What this one means is that when I come here, wherever I see x, I should put what lambda x instead of x. So I'm going to have lambda x plus lambda y, okay, all divided by lambda x minus lambda y. So we see this one. If I factorize lambda out, I have x plus y. Lambda out, I have x minus y. So it means that my dy dx equals lambda to the power 0 x plus y x minus y. So this is what you're going to get. Is that okay? So if you have something like this, this is beautiful. Now, since this one is giving us to the power 0, it satisfies the theorem. So you can say that this is what? Homogeneous. This is homogeneous. Okay. So let's move on. How, if we have pDE equation, if it is homogeneous, how do you solve it? Is that okay? How do you solve it when it is homo? Okay, so when it is homogeneous, this is how you go about it. First, you said that let y to be equals to ux, okay? Then you differentiate that. So you know that dy dx will be equals to, this is a product rule, so this will be x du dx plus what? U. You know how to differentiate. Hold this x, differentiate u, it will give you this multiplied by the x. Now hold you multiply, differentiate x, that will give you 1. 1 times u is u. That's what you have there. So what you're going to do is that when you come back to this place here, wherever I see dy dx, I'm going to put the whole of this one there. Wherever I see y, I'm going to put u to the power ux there. So let's see. So our dy dx is now x du dx plus u is equals to x plus by y is ux, all divided by x minus ux. So if you look at this one, this one, if I factorize x out, I'll have 1 plus u. If I factorize x out, I have 1 minus u. So you could see that this and this will cancel, leaving x du dx plus u equals 1 plus u, 1 minus u. Is that okay? So let me send this u to this side so that I have my x du dx to be equals 1 plus u over 1 minus u minus u. So we find LCM. So if you find LCM will be 1 minus u, right? I bet you 1 plus u minus u plus u squared, and this is dividing by 1 minus u. This and that will go, leaving 1 plus u squared, and that's what we have. So let's clean this side. Let me write the first solution. Let me write it there. C1 is equals to x squared plus y squared minus 2u. And also, let me write this one somewhere. Dy dx is equals to x plus y, x minus y. Also, let me write this, y equals ux. I'm going to use all this one later, okay? So let's start. This one is going to give us x du dx equals 1 plus u squared over 1 minus u. Okay, so this is what you're going to have. Now, where we are now, we can easily, separate them. So let's see. This goes here, and this one comes here. I'm going to have x du equals 1 plus u squared over 1 minus u dx. Okay, so at the end I'm going to have 1 minus u over 1 plus u squared du equals to dx over x, something like this, because I'll divide here by that. So that's what I'm going to get. Now here we can now integrate it. So let's see how this thing is integrated. If you want to integrate this, you have to do something. It's not anything difficult, okay? Good. So if you want to integrate, first thing to do, let's separate the numerators. So I have 1 over 1 plus u squared, okay, du, minus u over 1 plus u squared du is equals to integral of 1 over x dx. We all know that if you integrate, you get tan inverse, right? So this is going to be arctan. Some people write arctan, others write tan inverse. They are the same. So here will give you tan inverse of u. Then this side is going to be, you see, when I differentiate this, I will get 2u, which look like this, just that it's only 2 that is showing up here. So I'll bring that 2 out, which is half, okay? Ln 1 plus. So this is a function and a derivative. Then this is equal to ln x plus ln, let's say c2. So this is what I have. I have something like this. Let's see. This is ln x. So let me combine these two together. So I'm going to have tan inverse of u. If I multiply 2, it depends. If they have maintained here, that's going to be square root, right? But let me send it to the other side. This is going to be ln c2x plus half ln of 1 plus u squared. So this is what we have. So we have something like this. So this half, let me bring the half here, the square, so that it will become a square here. I hope you understand. If I multiply through, that one too will affect this. So okay, let me bring it up here. It doesn't change anything now. It doesn't matter. So this is what you're going to have, right? After getting this, the next thing to do is that, you see this and this, it means you should multiply them. So let's multiply. So we have tan inverse of u equals ln c2x bracket open 1 plus u squared half. Now you take e on both sides so that it comes like this. And I have my c2x 1 plus u squared half equals e to the power tan inverse of u. Is that okay? So I have to make c2 the subject. That e to the power tan inverse of u half. Something like this, right? But remember that the u is not needed here, okay? So we said we said some this thing here is here. Y equals u x. So if you make x the subject, sorry, u the subject, I'm going to have y over x. Means that whatever you see, you should put y x there. So c2 will be equals to e tan inverse of y over x, all divided by x bracket open 1 plus y squared over x squared half, like this. So this is what is going to be our final distance. So we have c2 here and we have c1 here. So I would prefer that c1 should be function of what, c2, something like this. So c1 is equals to function of c2. It means that my c1 is giving us x squared plus y squared minus 2u. It is here. Is equals to f of c2, which is e to the power tan all divided by x bracket open. Here if you find out, it will be x squared plus y squared over x squared. X squared plus y squared over x squared. Okay, good. And you know that this x will cancel one of this. So now let's see. So this become, okay, let me conclude. X squared plus y squared minus 2u should be f bracket open e tan inverse of y over x, or over this x will go into one of this, leaving x squared plus y squared over x. So this becomes our general solution. But we are told that we should use this as our initial condition, x0 equals x squared. So x is x, y is 0, u is x squared. So x is x, so x squared. Y is 0, 0 squared is 20, minus 2, u is x squared, so x squared, wherever you see u, you put x squared there, is equals to f bracket open e tan inverse of, you see we say y is 0, so if y is 0, y 0 over x will still be 0, so tan inverse of 0 x is x, so we have x squared plus y squared is 0, all over x. We have something like this. X squared minus 2x squared will give negative x squared is equals to f bracket open e to the power tan inverse of 0 is 0. Okay. And e to the power 0 all divided by this plus this will still be x squared. X squared by x is x. So I have negative x squared equals e to the power this will give you 1 over x. Okay. So in this case you can say that let p to be equals 1 over x. What it means is that so f at p is going to be, it means that when you come wherever you see x, you are going to put 1 over p there. So I'm going to have negative bracket open 1 over p is squared. So f at p is going to be negative 1 over p squared. Is that okay? Okay, so here it means that this one, let me forget about this. Let me take only this one. F bracket open e tan inverse of inverse of y over x all divided by x squared plus y squared all divided by x. So let me even, this x can come here, but let me maintain it here. Is equals to negative, so you see, it's just like you are going to take inverse of whatever that is here, because it's 1 over p squared. So it's going to be, the whole of this will go top and this will come down. So it's going to be like this, negative x squared plus y squared over x. And the whole of this is divided by e tan inverse of y over x. But remember, there is a square, so square. This x can come down here. So what is going to be here is that you are going to have negative x squared plus y squared all divided by x x e to the power tan inverse of y over x. So this is what you have. Is that okay? So we are able to find for the f. So we are going to put the whole of this in place of this, so that we get our final answer. So let me clean here. So therefore our final answer is going to be x squared plus y squared minus 2u equals, instead of this it's now this, so we have negative bracket open x squared